Hello, this is Dwight Mitchell from Mitchell and Son 3D Printing Services. My purpose of this little video is again just to show some of the projects that we've been working on and that we have worked on. Because I know I've gone on many times about trying to explain 3D printing and what it is and what it does, but it's part of the 3D printing is obviously creating the 3D models because which can be used in traditional manufacturing too. So without going on and on and on, I would like to show you, I'll just go to our Fusion 360 and show those. We'll just want to come to our Fusion 360 and show you guys just some of the stuff that we've done over the past couple of months since launching and since going on. So this is a 3D model of a BMW Alpine wheel cap. These wheel caps, I know for some of the Alpines you can still get on line, but this particular size is a customer who restores classic cars, and he bought himself an Alpine, but the wheel size of this, or the wheel cap of this, was 19 inches. You struggled to find, he struggled to find that specific size. So he asked me to redesign or reverse engineer it and then create the 3D model and then manufacture that for him, which we did. So we've created this. We used PETG plastic, which PETG plastic is your traditional garden tools. It's why I use 3D PETG is because it is more durable in the environment. So you've got your road dirt, your road water, and all that kind of stuff. That UV, being exposed to UV sun rays and all that kind of stuff, it makes it quite durable. Because if you think of PETG plastic, think what is that? Most your garden furniture, most of your garden tools will be made from PETG plastic. So it's quite a durable plastic. It's quite a hardy plastic, and it just makes it lasting and more enduring. I know the customer took this and he sprayed it to look like the other two, because he only had two wheel caps. He wanted all four, as you would want to, especially if you're restoring cars. So that is one of our projects which we've done over the last couple of months. We did this at the back end of last year, finished it early this year because there was a few issues I had with the design. Is creating, just stopping these little pins from snapping off. I 3D printing them. They create a solid base. So I ended up having to reinforce that with the structural enforcers over here, just to stop it from snapping off every time it was pushed into the wheel. One other one that we had, which was for a Land Rover. This is chappie bought a Land Rover. Again, it only had I think it only had two wheel caps. Two wheel caps. The chap came to me again, said he wanted me to reverse engineer it because he couldn't find these caps anywhere on the market. Gave me his original one, which is what we do, and then we were able to redraw that in CAD. Just go back to the design. So that was redrawn in CAD, and then we remanufactured that, reproduced that again in a PETG plastic, so that for the same reasons as the previous one, it's just more hardy, endures in environments, and just does what it's supposed to do. It won't get destroyed just by being in the environment with the road dirt and the sun rays and all that kind of stuff. It's just, again, quite thick. I think it was 3 millimeters with an 80% infill, giving it quite a lot of strength. For stones or whatever things. When the wheels get us changed, people can be quite rough with these type of things. So that is another project. Here's a project that we did for a customer. It's a boot catch. So this is again 3D printed, 100% infill in a PETG, but then you can also 3D print this in aluminium. So 3D printing in aluminium and then chrome plating it as you would traditional. So with the bolts in place, or the studs in place, that'll work as any cast aluminium. The difference is it'll be far cheaper. People say to me, well, when they print that in aluminium, you're looking about £300 or £400. They say, well, that's crazy. I can pick it up for 20, 30 quid. Yes, but if you can't find that on the market and they no longer produce those, to get that cast, you have to then, it's far more expensive. You have to make the pattern, casting it. You're looking at over easily £1,000 to cast that from scratch. Creating the patterns and then recasting that. You wouldn't be able to recast a single one-off or two-off as for a boot catch you would need two. But 3D printing that in aluminium, which is the same type of aluminium with the same metal properties as you would in casting, and then getting that chrome plated. So that is again a project that we did probably middle this time last year. This year is a project for a carburetor. Nowadays, the younger generation wouldn't know what a carburetor is. It was what distributed the fuel to your engine prior to injections, the injection systems, and even prior to what we have now with the electric cars on the way. But this is a carburetor for an old outboard motor, a Volvo outboard motor. They stopped producing these particular motor probably in the early 80s, and all spares would have stopped being produced on a mass process, or probably late 80s, early 90s. And so these floats were no longer available. More and more petrol engines and diesel engines now all injection. So carburetors is not something that your younger generation will understand. These floats, what happened was they cracked, so they leaked fuel into them, therefore they weren't floating to give you a proper fuel level and to work in the way that they were supposed to in a carburetor. Customer came to us and asked me to, again, reverse engineer these in CAD and reproduce them, which we did. We used a nylon material to reproduce these. Nylon is very durable when it comes to liquids or fuels sitting in petrol. They won't perish as much as or as quickly as other plastics. So nylon material was quite good, useful, and it worked. This is one of the very first 3D printing design jobs that I did for a customer. So it's almost 2 years old. This is my own personal project, which I did because we do a lot of street evangelism. My wife runs a bookshop, so I created a little free tract, gospel tract holder to be put on display in the open air. It has a wall mount, so if you wanted to mount that on your wall outside your house or in your church or in a bookshop, it can be. It would stick out a little bit, so probably more suitable for it to be sat on a flat surface. But yeah, that's something, again, I would also print that. I wouldn't use PLA, because PLA, unless you printed that with 100% PLA, but then again, yeah, that's a bit of a waste of time. PLA does end up crumbling and breaking quite quickly, especially if you've got it outside. So I would print that in either, I'm printing a sample at the moment in a resin, which is not too bad, but you can print that in PETG or ABS. Because of the lettering, why I've chosen resin, because the lettering, it'll come out better, and it's more suited to resin rather than or even a powder base. But then a powder base, using a powder based 3D printer is going to be a little bit more expensive to print this, but a powder based 3D print would do really well. And FDM, which is your desktop type 3D printers, you might struggle with the lettering. Resin, again, would work well. You wouldn't have a lot of support for the lettering because of the fact of the angle that it's at. So you wouldn't have a massive amount of support for the letterings and all that kind of stuff. This is a project. It's a chocolate mold, which again we print in silicon. So was probably February or January I designed this. It's for no, it was Christmas last year for a customer. It's a chocolate mold lips. So you got the lips on the outside. It's printed in silicon, which is just like your normal silicon that you would cast, but it's printed, making it cheaper, cost saving, and easier, less messy than trying to print or just cast in making a silicone mold. So this is 3D printed silicone. You pour the chocolate in, food safe. So you pour the chocolate in, you've got your chocolate lips. There we go. Others is a project that I did a few months ago, creating a 3D model of a wooden chair for a customer. So that, again, using leather material, wood, glass, and all that kind of stuff. So that was just a 3D model. This, again, a lady local to us had a watering can, which she really liked. The watering rose perished, obviously, because, again, PETG plastic will eventually perish if left in the sun, especially in direct sunlight for a prolonged period of times and over years, as plastic does, as you know, your own garden furniture. So she, instead of going and buying a new watering can, she really liked that watering can and had been given to her by someone that had sentimental value to her. So she asked me to redesign the watering rose and print that again in an orange PETG, so that when it comes back, that doesn't even look like it's, doesn't look different. And she keeps a sentimental watering can, which she had, and it's still useful because of the watering rose we've been able to do. We also do a lot of work for architects. So this is one recently, which we completed about 2 weeks ago and delivered. It's quite a large print. It was 1050 millimeter length with a 520 or 590 height. It's, again, just an ornate. So this I printed in PLA because it's going to have no forces applied to it. It's going to be stuck to a window. It's going to be decorated and painted, so protecting it from any outdoor, UV or anything like that. So that there, again, just an ornate thing. We ended up printing 2 copies of this because it was back and front of a window. And yeah, it's quite good. So we do a lot of work for architects. This particular architectural company, we've done about 5 or 6 different designs and prints for them. they do press ceilings, so you've got these ornate ceilings where you've got designs on the ceilings. So we've done designs for them and prints for them. This again is just not personal. For promotional purposes, I create, I find an archive of blueprints for classic cars or these old vintage racing cars. So I just redraw them in 3D in CAD, create a 3D model of them, and then create some little animations in Blender to, just for fun, for promotional purposes. But creating them, I do enjoy it. This is a project which is, we've been doing some experimenting and some trials with the Ford Anglia Club, the classic Ford Anglia Club. This is a Speedo drive on their cars. It obviously keeps breaking. Ford made about 4 or 5 different versions of it or variations of these. So what it is this is normally made out of steel, machined steel, and then we have your nylon gear bit at the bottom, and they end up perishing. So what we've been trying to do and working with their gearbox team is to create a solution whereby they can buy this in one single piece rather than buying, having that machine and then having this obviously machine out of nylon. So we have tried 3D printing these in nylon, but we found that they, because 3D printing is done in layers, they end up not being as durable as I had expected them to be. Through the wear and tear, the layers, especially on the gears, end up starting to come off. So I'm 3D printing. I've got one coming from production sometime this week. 3D printing this in a tough resin, which can reflect temperatures up to 200 degrees C. Hopefully, again, that will then be able to serve its purpose and have a solution for our guys at the Ford Anglia Classic Car Ford Anglia Club. This here is my latest project as well, one of the latest ones. It's a boot catch. It is again made out of PETG plastic. It's 100% in full because of the fact that it's high impact, especially here on the where the pins go in from the boot when you close the boot. So that needs to be very strong. It needs to be a solid plastic. PETG plastic, again, for all the various reasons that I've said in the past, is because of the fact that it's more durable. It withstands all the environmental and the dirt and all that kind of stuff. So it's quite a durable, but being 100% in full means it'll be have the same strength as if you printed that or had that injection molded. But again, to injection mold these, you think, well, okay, I'll injection mold them. You want a one-off. The cost is going to be about £3,000 or £4,000 to injection mold that. To 3D print that, I charge it. You've got the design charge in for the 3D model, and then printing it with 3D printing it is probably about 30 quid. 25, 30 quid because of the fact that it's 100% in full. So it's a solid piece of plastic once it's finished. So again, the cost saving, yes, you said £30 for a small piece of plastic is, you say that's expensive because you can buy something like that for about £5. But if you cannot find that on the market, if it's no longer available and you had that remanufactured, taking a piece of nylon to a CNC manufacturer and asking with all those, with all the detail that this piece has, would cost you at about £175 an hour for a CNC machinist. That would probably be about 2 to 3 hours. So you're looking at about 500 quid, or £300-400 easily to have that manufactured, to go to injection molder and say, well, could you injection mold that? Again, you're looking at easily just to create the mold for the injection is about £3,500 to £4,000, and then you'd have to pay £1,000 to get 1,000 of those. Because he's not going to just injection mold one and give it to you. He'd want you to buy at least 1,000, and you'd get them for £2.50 each a unit, but you'd have to buy 1,000. So the cost saving is huge. It's massive. Initially, when you look at it, you say, okay, you're paying the design of that, the design cost to create the 3D model, and then printing that, you're probably going to pay about £300 or £400. But if you look at the bigger picture, that's what you're going to look at. You're going to look at was now where this was never ever, where this is no longer available on the market. Same with all these other parts. You say, well, they're no longer available on the market. Once you got the 3D model, they are forever available. They will never, ever, never be unavailable. You can never say, well, those are no longer available. They are forever available because we've got the 3D model. So if somebody wants that made, you don't have to pay for the cost of designing that again. The 3D model's available. All you do is pay for the manufacturer, the 3D printer. That. So forever, while these electronic models are there on all of these, while the electronic model is there, that part is no longer an obsolete part because you have the 3D model available. It's never, ever again obsolete. That part where originally the guy couldn't find anywhere on the market a 19-inch wheel hub, forever, while I have that 3D model, that part is forever available. Just needs to be produced. It's never obsolete again. That's a wonder. That's a beauty of 3D printing. That part there is always available. So while these electronic models are available, that part is never obsolete ever again. That will never, and that's the wonder, the beauty of creating 3D models. Once you have the 3D model, it's there forever. Modern cars, modern technology, anything made in the last, say, 30, 40 years will have, or 30 years, will have a 3D model, or more than likely have a 3D model. Anything before that only has paper models or paper drawings, the technical drawing. So those things are unavailable. But once you bring it to someone like us, or any other engineering company where they can create a 3D model, that's what we do. We create the 3D model and it's forever available, making that part readily accessible. You don't have to try and create the molds like we did in the past, in the early days, in the traditional days, creating the patterns. It's there. And if you want a technical drawing of these things, very available. I can create from an item like this. We can create a technical drawing, and you've got the technical drawing to be able to reproduce that. We want to reproduce the traditional method. As you can see here, we've got, for instance, here, this is a pull stop from a traditional farm machine. Again, the guy, this particular farm machine or this farm instrument, this model, they couldn't find the pull start for it. So this is fits in the machine, starts the engine, so it's attached. So when you pull the string, it spins and starts the engine. Couldn't find it anywhere on the market. Came to us, and we were able to reproduce that, remanufacture or redesign it, reverse engineer it in CAD, and then make it again 100% PETG plastic, giving him giving it strength. But what I want to illustrate here is he also wanted a technical drawing of the item. Where's my technical drawing card? I do apologize. It seems to have vanished. Ah, there we go. So from the 3D model, we don't then have to draw anything else from that 3D model. So from that, we automatically can create the 3D technical drawings to be able to. So if you want that traditionally manufactured and you want a model, you want the details as this chap did, he wanted all the dimensions so that we could, or his own records. I'm not sure why he wanted it, but he wanted it. So we gave it to him. So we made that, we're able to reproduce that. So you can make this out of PETG and carbon fiber or polycarbonate or just a carbon fiber. But using, because of the fact that you've got quite a lot of pressure or a lot of stress on the around this, once you put the string in and you've got quite a lot of string, I would make sure that you've got a high infill. When I produced this, I made 100% infill just to give it strength. So you've got a solid plastic rather than something that will crumble and break. Because if you've got, like I said, 3D printing, you've got a honeycomb infill in the inside here. On here, it doesn't matter. On this surface here, on these outward surface, it doesn't matter if it's not 100% infill. Where the 100% infill matters is here, because on these, let me just, because when you pull the string, you're going to get a lot of force on these points here. And if they're not 100% infill, they're just going to break away because of the way 3D printing is. It's layers. So you've got these layers coming up here, as you can imagine. So if you put a lot of force on here and you haven't got 100% infill, these are just going to break away. They're not going to hold. They're not going to withstand the force. So making that 100%, even something like this, again, if I had to print that again, I'd probably do that in a resin, just to give it again higher strength, because the resin is just going to be, it's going to be stronger. It's just going to think. So I would even print that in a resin, or use a powder-based material rather than FDM to be able to manufacture that. So that is just some of the projects that we've done recently or over the last couple of months. And I wanted to share that with you, just so that we're not just, show you that we do the 3D printing, but that's not primarily. We also do the design. We also do the reverse engineering and some of the projects that we have done and we do. So I hope that was informative to you. This is Dwight Mitchell from Mitchell & Son 3D Printing. Yes, drop us a line on my landline is, read it out loud, is 023-8124-4996. You can give me a call on 07876131539 or drop me an email at dwight@mitchellson.co.uk. That's Dwight, D-W-I-G-H-T, at mitchellson.co.uk. Thank you for listening. Thank you for your time.